So you see the wire is there. So this wire diameter is 0.8 mm, and this is the complete automatic mechanism. So wire will become feed automatically, and the arc will be produced here on this sheet. This is our substrate. Substrate is of mild steel. So we will see how the welding takes place. So we will make a layer by layer manufacturing. That is the additive manufacturing process of the metal. So I'll continue to Manish.
Thank you, sir. So once again, good afternoon, everyone. As sir has already told about the additive manufacturing processes. So before going to this particular machine setup, we will I will describe about the brief of additive manufacturing process. How after that we will reach to the wire arc additive manufacturing process. So firstly, additive manufacturing is the basically layer by layer deposition of the material, that the making a part through the layer by layer and making a complete complex part or geometry that we want to make, or that has its finalized application. That is known as the additive manufacturing, or it can also be defined as the making any part without using any cutter, any specific fixture, with the help of the computer CAD designs. So if I talk about the additive manufacturing, ASTM ISO ASTM is divided additive manufacturing in very 7 broad categories. In 7 broad categories, additive manufacturing processes are classified. Earlier, if I start, first one is the wet photopolymerization, second one is binder jetting, third one is extrusion process, fourth one is a sheet lamination, fifth one is a powder bed fusion, and another one is the extrusion process, and last one is the directed energy deposition process. All those processes are on the basis of the amount of heat input is being supplied during the process. During the process, the amount of the heat is supplied is the basis of the classification of these additive manufacturing process. From wet photopolymerization to directed energy deposition, there is an increase in the amount of the heat supplied. So now, raw material, depending upon the available power source, depending upon the amount of the heat needed, different additive manufacturing processes are used. Earlier, recent time, mostly powder bed fusion or direct energy deposition methods has got very highly attention due to their very high accuracy part and due to make their complex part in case of the metal additive manufacturing. Although powder bed fusion has a very high rate of accuracy in which the raw material is used in the powder form. But the point is that due to the even being the high accuracy of making the high complex part, there are some challenges using the powder bed fusion in every places. First one is as a raw material, that is in form of the powder. So it is also make the unhealthier to the human environment. Second one is the operational cost. The overall costing of the powder bed fusion setup is very high. Operational cost, material cost, and overall maintenance cost is also very high. So that's why we move further to on the basis of the directed energy deposition method. So basically, I classified additive manufacturing processes on the basis of the heat input supplied from wet photopolymerization to directed energy deposition method, in which I talked about the metal additive manufacturing process that is most prominently are used by powder bed fusion or directed energy deposition. In powder bed fusion, as I told you that there are some challenges regarding to the cost, regarding to the as a raw material in form of the powder. Other operational challenges also there. So that's why now we are shifting to the directed energy deposition method. So now in the directed energy deposition method, there are depending upon the availability of the raw material, availability of the power source, it can also be further classified. Directed energy deposition, in the directed energy deposition, what we do is initially we use the thermal energy to melt the material and deposit it layer by layer. Now, if I further classify directed energy deposition method into different categories. So one category, as I told you about the raw material that we are using and thermal power source that we are using. So one of the category is wire arc additive manufacturing process, in which raw material is considered as the form of the wire and thermal energy source is used to melt this wire and to make it deposited in the form of the layer by layer process to make a complete 3D part. As this is the third day and we have already gone through the very long way that we know that how the 3D printed part make. Before coming to this particular setup, I will just take a brief about the process and then we will move to the machine setup. So as we earlier also told that to make any 3D part, what we need in the 3D printing, first we need scanning of any product or any part that we want to make. That is done with the help of the CAD modeling or computer modeling. The part that we want to make, first we need to make it a CAD design. After in the CAD design, after making the CAD design, the computer, the software make it the next step of slicing. What does it mean by slicing? Slicing is done with the layer by layer so that accordingly information can be get. And after that it generates the some codes and those codes are given to the machine to print in the form of the layer by layer. So that was the basic concept behind the additive manufacturing that we discussed. I discussed about the additive manufacturing and its classifications. Then I discussed about the directed energy deposition method. So now on the basis of the availability that we have in the form of the raw material, that is wire, and available the power source, that create a category in the direct energy deposition method is wire arc additive manufacturing. What does that mean? That is called as WAM, wire arc additive manufacturing. Wire means raw material in the form of the wire. Arc is a process of creating the thermal energy to the for melting process. So depending upon, as we have decided the wire first as a raw material, now the priority is the how we are giving the thermal energy in the form of the arc. That arc can be generated by different mode. That can be in the with the help of MIG machine, that the metal inert gas machine, that can be in the form from the TIG basis, that can be on the basis of the plasma basis, and that can be in the form of the laser basis also. So again, on the basis of, firstly we decided the wire as a raw material, that is create the category of the wire form of the WAM. Now then we go through the power of energy that we are supplying. On the basis of that, we also created the category of the WAM. That is, if we are supplying thermal energy with the help of the MIG basis, that it is called GMAW basis WAM. Second, if we supplied the thermal energy with the help of the TIG basis, then it is called as TIG basis WAM. If we are supplying thermal energy on the basis of the plasma basis, then it is called as the plasma based WAM. Or if we are using laser power in the directed energy deposition, then it is also called as the laser based directed energy deposition. So LPPF is a one process and directed energy deposition is another process. So now here we are showing you that schematic dedicated the MIG based wire arc additive manufacturing setup, in which there are some component of this particular setup. First, as I told you, the basic start from the wire source, that the consumable wire we are using over here. Second one is the power source, that is the very important, that we are using is the MIG based. So we will see every component very clear way. So here we can see that this is the wire feeder. With the help of this continuous is given to the torch, and this is the power source, that is to provide the thermal energy to melting of the wire. So this torch, this dedicated MIG torch is connected to a setup that is known as the CNC router setup or CNC controller setup. As I told you, we are making is a 3D part. So what we need is, we have to create two segments. First is the energy part. Second one is a robotic part, that is creating the complete 3D product. So in the thermal energy part, we are giving the power with the help of the MIG machine that I show you. After that, this is known as the CNC controller. This is known as the CNC setup, this is CNC router, and this is controller. This is what? CNC router. This is CNC controller. In this CNC router, there are 3 axis movement in the direction of X, in the direction of Y, and in the direction of the Z. These axes are controlled with the help of the stepper motor. These are the stepper motors in all the 3 directions. Stepper motors are connected to give the movement to to give the movement of the 2 torques. This base of the XYZ router is made of the aluminum grade. Aluminum is a very light material, so that's why aluminum material is used to making this base. This is the known as the XYZ router, and this router is connected to the controller. This is the DDCS controller. DDCS controller. Again, what I told you, XYZ router, in which X, Y, and Z direction of the torch movement is controlled with the help of the stepper motor. Then this control signal is given with the given by the CNC controller that is next to you. Now, what we have done with the MIG basis source, we have connected this torch to the in the Z direction. Here we have mounted a workpiece in which the deposition of the metal will takes place. Some key inputs are needed to making a different part, so I will come on that also. This is the controller. All these setup can be also run with the help of the software basis. So what we can do, we can control X, Y, and Z direction motion with the help of either this MPG, manual portable movement. We can control with this also, and we can control with this also, and we can also control this on the basis of the computer software. The dedicatedly software is used. The movement is MAC3 software, is known as MAC3 software. Again, I am repeating the CNC part, CNC router part. This is the controller part. The control part is used to control the XYZ movement with the help of the signal to the stepper motor. And this control can also be done with the help of the MAC3 software in the CNC controller. We have to give the inputs and outputs. So now, before making any design, so before coming to the design, I will also show some important part of this mix setup. Then I will go for how we make a 3D printed part. So we will see that there is also the wire feeder is also connected to the gas cylinder. Gas cylinder. This is basically argon gas cylinder, and the we are using over here is SS308L. Stainless steel 308L series that we are taking the consumable wire with diameter of the 0.8 mm. So very important part during the operation, what we need, the diameter whichever we are choosing, it should be the component, small component that are used in the either in wire feeder or in torch should be of the same diameter. I am again repeating, the diameter, whatever diameter we are choosing, accordingly we should select the few minute component of either wire feeder or the torch. In the case of the, I am talking about wire feeder, the roller through which the wire passes during the operation should be of the same diameter. I am repeating, if I am using the spool of 0.8 mm diameter, the roller that are used in the wire feeder should also be of the 0.8 mm diameter. Otherwise, when during the operation, when wire will continuously come out, it will slip, and again the process will continuously stop due to the continuous binding of that wire over there. Similarly, the nozzle here, the nozzle that we are using, the contact tip inside the nozzle that we use, that should also be the accordingly that wire should get easily passed through the nozzle. So these are some important parameters that we should keep in mind before the operation. And also the shielding gas also be as per the material requirement. So these are some basic inputs that we also need. Also during the operation, that we should, before performing the operation, we should also be ensured that in the machine setup, either these are on the solid mode or not. The wire that we are providing in the solid mode. So when we do these operations, so these are the basic instructions that need to be carried out. So now this part I have told. So before making any here, before making any part, what we need, we have to just characterize particularly single bead deposition. Before starting the deposition, as we are what, suppose we have to create a single wall structure over here. So what we need to this, have to as I told you, either we can go through the scanning part, then we can directly print the 3D printed part. So here, before to create a 3D printed single wall structure, what we need, we needed steady state responses. Actually, point is that before making any hit and trial experiment, what we have to do, we will create some beads on the basis of the hit and trial experiment. On the basis of that, we decided the input parameter accordingly design matrix. Suppose we want to make a single wall structure of any material of suppose SS308L material. So we, what should be the my input parameter accordingly that I can get my best welding best welded part, yeah, best 3D printed part. So in order to decide the which parameter is most significant, which parameter should the value, what should be the value of the parameter so that I can get the very sound well, we need to go with the design of experiment method. With the design of experiment method. I would like to repeat what I said. I said if we wanted to make a 3D printed part, before that, to making any 3D printed part, we need some input parameters so that we can get very sound weld or sound 3D printed part. Suppose in the MIG machine, what we need, some voltage as an input parameter, travel speed is an input parameter, and the what should be the value of the current, and what should be value of the nozzle to tip distance, what should be the value of the gas flow rate. So all those parameters needs to be decided in order to get the appropriate and very sound additively manufactured part. For that, we needed the design matrix. Suppose design matrix, accordingly design matrix, we do some hit and trial experiments. On the basis of the experiment, we need to get the appropriate range, we need to get the appropriate parameters of the for depositing the material, and accordingly then we go for printing of the final part. So suppose we have to deposit this SS308L material. So for that, what we will do, we will create a design matrix. Accordingly, design matrix, if we, here are the two types of the design matrix. Earlier in after this lab session, Yashwant sir will also tell about the design matrix also. So I will not go into the depth part. So I will just giving you the brief about the design matrix. So accordingly, CCD design, we create a complete design matrix, design of experiment that we create on accordingly, depending upon the parameter we want to study, depending upon the parameters that we want to get the value, we will decide the design of experiment. So suppose we get the 13 design of experiment according to the design matrix, we perform each experiment, yani that is the 13 experiment, 13 beads are being fabricated, and from for each bead, the cross section, depth penetration, bead height, every aspect of the bead geometry is calculated. Again, I am repeating, after performing these 13 experiment or the design of experiment, the all the aspect of the bead geometries are calculated, and then after, with the help of the images software and design expert, we find, we run some confirmation test, then we find the finalized value of the input parameter in order to get the best additively manufactured part. Initially, what we do, we create, suppose we want to create, we want to see the impact of the two important parameter, that is voltage and travel speed. First, we need to give some hit and trial experiment to give to give some range to the software, that at what value of the voltage, at what value of the travel speed, the bead that is appearing, that is good or bad. So accordingly, that we decide on the basis of the literature and hit and trial basis the range of those parameters. After that, those parameters are given to the design expert software, and that created accordingly design of experiment. That number of experiment are created, and we perform those experiment on the on this machine setup. And those, after those experiment, every, for every experiment uh, we measure basically all the bead geometry, all the bead profile, then like what is the bead height, what is the bead reinforcement, what is the penetration, what is the complete depth, and what is the reinforced area, and what is the dilution percentage. So accordingly, when we put these data to the software and optimize these process parameter, then we get the value of the optimized process parameter that will give the best additively manufactured part. And then we finalize, then we finally run the experiment over here and create the 3D printed part. To giving the motion, we needed the codes accordingly. And one important part is that as we talk about the metal deposition over here, MIG based VAM is the MIG based VAM has the very high deposition rate. That's why we uses this setup. In comparison to the TIG, in comparison to the plasma based VAM, it is very high deposition rate, up to 4 to 5 kg per hour. So that's why it is used. The advanced version of MIG is also the morning classes session. Sir takes, Yashwant sir takes the session about the CMT, cold metal transfer, in which at the low heat input, we get the higher accuracy, higher deposition. So that is the advanced version of this GMAW basis setup. I hope you are getting my point, that how we create the bead, how we design the optimize with the help of the software. With the help of the software, we get some parameters. On those parameters, we analyze that bead geometries, bead parameters, and then after that, we perform the complete experiment to make the 3D printed part. So now, accordingly, so,
So, dear participant, there are some technical issues are occurring during the lab session. So, session will start shortly at 3 o'clock. So, sorry for inconvenience. We will again meet you at 3 o'clock.
आ रहा है? हैं? नहीं चल रही क्या? तो फिर हम्म,
आवाज या तो आप मोबाइल में चला के देगा।
यूट्यूब को मोबाइल में चलाऊं?
यहाँ से चल रहा है तो पहले मोबाइल में चला लो तो बाद में
मतलब इसको तो यहाँ से चला दूं
हाँ आवाज आवाज
और इसके लिए आवाज के लिए या फोन में कनेक्ट हो
हाँ
तो फिर मुझे किसी और जने को कनेक्ट करना पड़ेगा।
मोबाइल तक कर देते हो
नहीं, आप समझे नहीं। तो मोबाइल में कनेक्ट करना पड़ेगा ना, वीडियो दिखाते रहेंगे मोबाइल से।
चल रहा है कनेक्ट हो रहा है यूट्यूब पे तो बस आप आपके मोबाइल में यूट्यूब पर बस कर देंगे ना तो इस मोबाइल से आवाज दीजिए।
मैं समझ नहीं पा रहा हूँ।
अरे अपन बोल रहे हैं
हाँ
आपका यूट्यूब है तो उससे आवाज आ रही है इसमें
हाँ
यूट्यूब पे ये चलेगा
हाँ
मोबाइल पे वीडियो
हाँ।
उसके बाद आपके लैपटॉप में जाएगी
अभी मुझे क्या करना है ये बताओ, क्या करूँ मैं?
मोबाइल में यूट्यूब चलाओ जहाँ से वीडियो स्टार्ट करते हो वही चीज तो यूट्यूब को स्टार्ट करके मोबाइल में लैपटॉप के पास छोड़ दो।
एक सेकंड रुको।
कट करता हूँ मैं इसको ना।
रुको, आप ये कह रहे हो कि ये मैंने यूट्यूब वाली वीडियो इसमें चलाई एंड और यहाँ से ये ये है लगभग 1852 यानी 1729।